center of mass, or COM. I've drawn a very scary structure here. It's a two-dimensional structure. It's made of 6 square masses separated with these thin rods that we are going to ignore the mass of those rods, saying that they're a lot less than what these big masses are. So dimensions are vertically 1 meter up, and across here 1 meter plus 2, so that's a total of 3 meters. And we're going to say these are all 10 kilograms. Alright, when we're looking at center of mass, our center of mass equation is x center of mass is going to be adding up all the masses times their distance over the total mass. Now what's important is that distance is always measured from the same location. Just like if you're into drafting or do AutoCAD or architecture, you're always going to measure everything from the same point, or building houses too. So we're going to measure everything from here and call that x equals 0, and then everything be measured positive that way. So as we go across here, we're going to have the 110 times 0 because it's right on the axes, another 10 times 0. That's that second one up here. We'll have a 40 that's at 1 plus a 5 that's also at 1. Right? These are both at 1 meter away. And we have to add in there here this last 10 on the end. That's at 3 meters. Plus the 50 that is also at 3 meters. Again, it's 3 meters measured from here, and we're going horizontally. Alright, that whole mess will be over the total mass. Now we add up everybody that's on top there. We have to include everybody, even if they're sitting on the x equals 0 location line. So we're going to have a 10 and another 10 plus a 40 plus a 5 plus a 10 plus a 50. Oh boy, let's see if we can keep track of this. On the bottom we'll have 20, 60, 70, 125, I think. Somebody wants to correct me on that. 30, 80, 125. Looks good. Up top we'll have 0 plus 0 plus 40 plus 5 plus 30 plus 150. And what does that give us on top? 72, 225 over 125. And if we get out our calculator and look at that, 225 divided by 125 gives us a 1.8 meters. Now what does that mean? That means the x center of mass, or the center of mass of this object, is going to lie on the 1.8 meter line. So if I drew a line here vertically at 1.8 meters, that the horizontal balance point or center of mass is going to lie along that line here in the structure. Now how do I find out where it is? Well, to find out where it is, I have to go back and find out what the y center of mass is. Let's see if I have time to do that. We add up all the my's over total, and everything will still be over 125. I'm going to do this quickly. We have to measure vertically, so it's 10 times 0, 40 times 0, 10 times 0. Here we're going to have a 10 times 1 plus a 5 times 1 plus a 50 times 1. Again, we're measuring everything vertically. That's the y-axis. And these are all zeros because we're using this as our starting point. That's going to give us a 10 plus a 5 and a 50. What's that? 65 over 125, which would be 0.52 meters. That tells if we draw a line at 0.52 meters up from that point we're measuring everybody, that will be the balance point vertically. If we go through and look at the connection or the intersection of those 2 points, the center of mass of this entire structure would be located at a point 1.8 meters, 0.52 meters, and if we needed a z-coordinate, since this is a two-dimensional object, we would put 0 meters because it doesn't have any thickness to it. It's not a volume. So that would be our center of mass. That's the point. If we threw it, it would spin about. If we balanced it, it would bounce about. That's where we consider all the mass. So hope that problem was good for you, and we'll look for your next video.